This is Algebra 101, Algebra 101. In this video, we're going to just review a couple concepts that you should have learned in a pre-algebra class. By taking Algebra 101, it's assumed that you have had some type of pre-algebra class, because we're going to start right in on some algebraic expressions today and translating word phrases. So hopefully some of these things will be familiar to you. If not, you may want to go back and review a little bit of, or if it's been a while since you've had pre-algebra, review a little bit of pre-algebra to get into this. If you need help with this, of course, you can contact us and we'll help you. And if you need some more review of material before this, we'll kind of give that to you as well. I just want to review very quickly the order of operations. This is something that you've done since probably late elementary, early middle school math. You've probably heard the expression, please excuse my dear Aunt Sally. You know, the P for please, E for excuse, M for my dear Aunt Sally. But we remember to do our parentheses first, and then our exponents, then our multiplication and division kind of from left to right, and our addition and subtraction from left to right. So that's the order of operations, and that's all I'm going to say about that at this time, except it's very important when we get into these long equations and these long inequalities and different types of problems that we're doing, that you remember that order of operations. So the next thing I want to touch on very quickly to review will be exponents. As you know, exponents work with variables the same way they do with real numbers. If we have a 2 and we have a 3, this is our base, this is our exponent here, and that's 2 to the third power, or in this case we could say 2 cubed, okay, which basically means 2 times 2 times 2, okay, that's what 2 cubed means. Well, when we do variables, we can do that the same way. If I take an x and I raise it to the third power, that's the same as x cubed, which is the same as x times x times x. So the exponents work the same way with variables as they do with numbers. So if we have an expression 6y squared, well, that square only applies to the y. It does not apply to the 6. So this is the same as 6 times y times y. The 2 only goes to the y. Now, if this was in parentheses, like this, 6y, and this was in parentheses with a squared out there, then that would be the same as 6y times 6y, because that square would go for everything inside of the parentheses. Sometimes you may see something along these lines, 7 times A times A times B times B. Well, if we had that and we wanted to simplify that using exponents, we would go 7a squared b squared. So that's kind of the way we do exponents in this. So you'll have, that should be a review for you. Hopefully you've had that in the past, and you'll have some problems to practice with that on your assignments this week. So if that gives you any problems, then we'll get you some extra help with that. But I wanted just to touch on that quickly, just to remind you a little bit about exponents and a little bit about the order of operations. And I want to go ahead and go into translating word phrases into algebra, because this is something that's difficult for some students, and it's just tricky the way some of these phrases are read, and so we understand these properly. Many times we'll have we'll have situations that'll say 3 more than a number. So a number is what we don't know. So for a number, we're going to use a variable. And we can use any variable. A lot of times I like to use X, but you can use anything. You could use Y, you can put an A there. But this represents a number. And some people would put an N for number. But let's just put an X for now. So 3 more than a number. So if we have a number and we want 3 more than that number, then we just simply add 3 to it. Now we're not solving this for anything at this point. We're just trying to evaluate these word phrases into an algebraic expression. Okay, so this represents 3 more than a number. Now, what if we want a number increased by 5? So we put a number increased means to add by 5. So there's a lot of different ways that you can word plus, addition. So some key words for addition, you may hear words like exceed or gain or increased by, more than, plus, and of course the sum. A lot of times you'll hear the sum of a number and 2. So if I said a sum and a number, well, I'll just put N for number. Like I said, it doesn't matter what letter you use. A number, the sum of a number and 2. Well, if you remember, sum is the answer in an addition problem. So you would just add that together. So those are different ways that you may use some addition. Some subtraction terms you may hear is the difference. Remember, the difference is the answer in a subtraction problem. Decreased, if something decreases, it's subtraction. Less than or less, minus, words like those are things that would indicate subtraction. So let's try a few of those and see what we end up with. So if I said I had a number decreased by 4, well, there would be a number, we'll use X for a number, decreased by 4. Now you have to be careful with subtraction because the way it's worded is different. Addition, the order doesn't matter so much. But in subtraction it does. This is a number, there's a number, decreased by 4. What if I said 4 decreased by a number? Well, you would have to start with 4 and then you decrease it by a number. So this is 2 totally different problems there. And you're going to get 2 different answers with this problem. So it's important that you read these phrases very carefully. Okay? So let's try 8 less than a number. So let's put a number first. We'll use Y for our number this time. There's a Y. And 8 less than that would be Y minus 8. Now, if we said 8 less a number, I would go 8 subtract the number. So this is 8 subtract a number. This is a number subtract 8. So when you read it, this is a number less 8. This is 8 less a number. So very, very tricky the way that shows up. Even the word than makes a big difference. For example, I could say this is 8 less than a number. This is 8 less than a number. So I'd have to have the number and I subtract 8 for that. But if I said 8 less a number, then it would be the number 8, and I would subtract the number. So that even the word than in that makes a big difference. So this is 8 less than a number. It was right there. This is just, well, this should be less. And this is 8 less a number. This is 8 less than, this is 8 less. So you see the difference and how just a tiny difference in the phrase makes a difference in your answer there. So let's do a few more of these. Let's go to some multiplication. For multiplication, you could use words like twice or triple or 3 times or 4 times. You could use the product. Remember, product is the answer of your multiplication problems. So if I said twice a number, okay, here we'll just use x as our number again. There's our number. What if I want to go twice that? Well, you could go x times 2. And that would be correct, but the more proper way to write it, the way that you'll see it more often, will be 2x, which means 2 times x. So the commutative property here, remember, you can go x times 2 or 2 times x, it's the same thing, but the way that you'll normally see it is 2x. Okay, so if we said quadruple a number, well, what does quadruple mean? That's 4 times. So if we said quadruple a number, we would go 4x. That would be 4 times x. So if we said in some division problems, we could say 6 divided by a number. 6 divided by a number. So that would be 6 divided by a number. Now, that's another one to be very careful with. You would want to make sure that the 6 is on top because you're dividing by the number. If you said a number divided by 6, it would be 1/6 or a sixth of something. So a number divided by 6. So that's the difference. You've got to be very careful when you do that. So watch that. A ratio is another way to show division. If I said the ratio of a number and 12, well, I could go 1 to 12 ratio. That's the way that you may have seen ratio in the past, but it's also a division problem. So if I wanted to say a number and ratio 12, then I would put an x here. That's the ratio of a number and 12, or I could simply put the x over 12. That should be a 12. Almost looks like a subscript there. Let's see. There we go. So that would be that could be used as division or a ratio or a quotient. Quotient is your answer in a division problem. So those are some keywords that you want to listen for when you're doing these. And then sometimes you will hear equal or equality, and we can actually put some of these in to start to form an equation. What if we had 3 more than a number is 18? 3 more than a number is 18. We'll just break it down into phrases. Okay, 3 more than a number. We don't know what our number is. I'm going to put n for number. 3 more than that would be n plus 3. And it says 3 more than a number is 18. So I would put equals 18. And then I could solve that equation if I wanted to, but we're not doing that right now. We're just, here again, we're just setting up some problems. Let's do just a couple more. Let's do twice a number decreased by the number equals 4. So twice a number, that would be 2 times a number. We'll use x for a number this time. Twice a number decreased by a number. So I would subtract the number. Well, I used x for a number. Twice a number decreased by a number equals 4. I'll put my equal sign and I put 4 there. Okay, so that is twice a number decreased by a number equals 4. Okay, so let's do one more, and then we'll let you work on some of these on your own. Listen to this one. See if you can write this one out first on your own. 8 less than triple a number gives 28. So listen to that again. 8 less than triple a number gives 28. See if you can figure that one out. Write that one down. Pause this if you need to. I'll read it one more time. 8 less than I messed that up. 8 less than triple a number gives 28. Okay, so now let me write it up here, see if this is what you came up with. So if I have triple a number, that would be 3x. That's triple a number. Now I want 8 less than triple a number, so I would have subtract 8. This is 8 less than triple. That's triple a number minus 8. And it gives you 28. So that was gives is the same as equal. So for equals, it could say yield, it could say give, it could say a lot of different things there. But equals produces, yields, gives, those sort of things. Is where you put your equal sign and have an equation. All right, so those should be kind of fun for you to work on. And try that, and then we will do some more next time.